Morning. So good morning, everyone. Hopefully my voice stands up to this. So Captain Alex, Commander Kyle, Davis, Himanshi, Jordan, Jake, Lemon Juices, Moretta, Robert, Potato Evo, Red Helix, Rubber Slayer, Rizak, Sapphire Gates, oops, Standing Wave, Tap Daddy, good morning, everybody. Probably hearing an echo. Okay, I got rid of that. Okay, so we have a little bit of makeup to do from the week before spring break to help everybody get finished with Lab 7. And then we'll move straight into Lab 8. So normally what will happen is I will, on the Tuesdays, kind of talk about the overarching concepts for the week, and then on Thursday I will do hopefully a well-paced, sort of a slow walkthrough of that week's lab. So apologies in advance, because some of you probably don't like to get all the spoilers like this, but since I don't have the ability to stand over your shoulder and sort of watch you work and step in and help you, I feel like my best option to make sure everyone gets what they need is to just walk you through it. So you still have the projects, and those are still sort of independent work. So you still do have sort of plenty of space to work the problems on your own. You can also work ahead since all the labs are posted. So if you want to do that, hold on, I'm already getting a scratch in my voice. You can always work ahead, or you can wait to view the video instead of attending the broadcast. You can wait to view the video until later. You can always email me questions, and of course you can use chat to ask questions. Don't be shy about that. So, but what I will do is kind of very quickly, since we lost Tuesday this week, very quickly I'll tell you what the concepts are that we're dealing with, and then I'll go into Lab 7, and then probably take, like a minute break, because I bet I'll be out of tea by then, and then we'll do Lab 8 together is my plan. So let me bring my notes up. So this is CSCI, if I can type. CSCI 21 for the 26th. All right, so the concepts. So we're learning how to use standard vector, which is a dynamic array of sorts. And what I mean by that is it grows as you add things. It shrinks as you remove things. So that's what I mean by the vector being a dynamic array. It grows as you add things. It shrinks as you remove things dynamically. A traditional array in computer science is a fixed size collection. Sorry, my voice is really roughed up. A standard array is sort of the fundamental collection in computer science, and in most languages, that is a fixed size collection, meaning if you create it to contain 10 items, it can't grow and it can't shrink. It will always be 10 items. A standard vector, on the other hand, will grow every time you add things, and it will shrink every time you remove things. So it's dynamic in that sense. So that's the star data structure of the week. We're also dealing with strings, which are also, but they're kind of a collection of characters, which we talked about before spring break. So strings are also in here as well. It turns out that strings are very similar to arrays and vectors, so I'll point that out when we're taking advantage of the fact that strings are themselves collections. So more generally, what we're trying to do is introduce you to some of the basic concepts of the C++ standard library collections. Most of them have a size function, as an example, almost all of them, you need to be able to iterate over them, meaning to process all elements in the collection. The traditional way to iterate an array, as an example, is a for loop in most languages. It's got honey in it, but it's not doing anything. So we're looking at how, using the size, how do you iterate different collections? So that's, for now anyway, sort of the big stuff. And then we're also doing use your own functions. That's kind of Lab 7 stuff. So what I've done is set up Lab 7 to reward you if you figure out how to use the functions that you yourself have created as a part of the lab. And I'll point that out when I'm doing it so you see what I mean. The concepts in Lab 8. There's really only one concept in Lab 8, which is creating a class to manage a collection. So what you're going to be doing for pretty much the rest of the semester is you're going to be writing code that manages collections of data. You can think of it as different ways of implementing databases in C++. But what this usually means is when we say managing collection, what we usually mean is having a private member that is a collection, which I'll point out to you on Lab 8. Having functions that perform CRUD. And I'll tell you what CRUD means, but it's a computer science-y thing, so you should know what it is. So CRUD. The C part of CRUD means to create, or often we'll say add an element to a collection. The R part means to read or retrieve an element from a collection. The U, you could probably guess, is to update an element in place in a collection. And then the D part is to delete or remove an element from a collection. I'll point it out to you when these things are happening. But anyway, that's Lab 8 is going to be doing this CRUD stuff as a means of creating a class that manages a collection, which is much of what the rest of the semester is. So I will remind you of these things after the 1 minute or so break between labs. But now I'm going to open up and start having my crack at lab number 7. And feel free to use chat to ask questions if you have any. I feel like my camera angle is not the best for you, but probably good enough. It's not like you need to see me really, is it? That is slightly better. Okay. Don't let me forget also. If I forget, let me get this where I can see it. If I forget, you probably can't read that, but I need to ask you about setting up a Slack or a Discord channel for the class if you have an interest in that. So if I forget, that's the thing that I'm going to do right at the very end after I've gone through everything else is poll everybody in chat about using Slack or Discord to give you an additional means of communicating with me and other people in the class. Okay, so where were we at? Oh, this lab. So Lab 7, and I'm not going to bring up the, come on, man. Lab 7 has 4 files in it, so it has a word list. This will be input that the program uses to test the code. It has lab7.cpp, which is unit testing? Did I mess up the screen for you at all? A little bit. A little bit. Okay. Lab 7 is the unit tests. Functions.h is the header file, and I created all those headers with documentation about what each function is supposed to do. And then functions.cpp is where you implement the function. So we're going to start having a crack at that. So the way I go about this is I usually take all of the function headers and copy them from the .h file into the .cpp file. So here they're all copied in here in the CPP file. I have my include for functions.h so that all the definitions are read. I usually strip the comments out at a point, although for now I'm going to leave the comments in so that I know what to do with the functions. All right, so here's my workflow. First thing I do is I remove the semicolons and set up the blocks to be filled in with code. And I'm just going to go down. Actually, let's do one function at a time. So what you're about to see me do is called stubbing the function. And stubbing a function means that you make it so that it will compile even though it's not actually doing the job it's supposed to do yet. So my first step is I'm going to stub it out. The main problem with this function is it's supposed to return a vector of strings. And to stub a function that returns a value, you have to return a value that matches. So the way I'm going to deal with this is I'm going to create a vector of strings called result and then return it. Hopefully all the, if you, please in chat, if you see anything kind of not working right, or if you see me make a mistake, please jump in. Okay, so this is called stubbing the function. It doesn't actually read a file. It doesn't do anything with the file name. But what it does do is it returns a value which is enough to satisfy the compiler. What it returns is an empty vector. It'll satisfy the compiler, but probably not the test. So that's a stub. And I'm going to go down through and just stub them all out. So I can get rid of this string processing comment. So to stub out this to upper, I have to return a string. So I will just make myself a string result and then return that. That will satisfy the compiler. It probably won't pass most of the tests. And then I'll just kind of rinse and repeat. So to lower also returns a string. So I will make one. When I come back, of course, I'm going to have to do the code to make the result. This one returns an unsigned integer, digits. So I will make myself an unsigned integer called result. And then return the result. Now I'm going to speed up a little bit because I think you get the idea. Plus you can watch the video later and slow me down. This one also returns punctuation. So I will make myself an unsigned integer. Zero it out to start because that's good practice in C++. So these are all stubs. There's just barely enough code in there that the compiler will let me get away with it. Even though I know I'm not going to pass most of the tests. This one also returns an unsigned integer. I can remove these sections because I know this is the vector section. So now I'm down in the vector function. So also an unsigned integer. So same thing. What I'm trying to do by stubbing is just get to a compiling state. Yes, Jack asked about the semicolon at the end of the function. Not only can be, should be deleted. So just get rid of it. Good question. That semicolon is only there for the function headers in the .h file. Oh, by the way, one thing I didn't point out, these functions, let me get that file open. These functions in the .h file, they're not inside of a class. So I'm not doing anything : over here because they're not inside of a class. So yeah, to stub a function so that I can get to where I can get an initial compile just to feel good. Get rid of the semicolon and then create the block for the implementation. All digits. If I can spell. Signed, int, result. I'm leaving the extra blank line because that's where I'm going to go back later and do the work. All punctuation. Not everyone works this way, but I like to sort of always be compiling or near to compiling. So that's why I'm doing this stubbing, just so I can immediately try to compile. And then I'll focus in on one function at a time. All right, so there's all my functions stubbed out. So now I'm going to go to my terminal and I will compile. I'm going to do a listing here just to show you that there's two .cpp files. And to do a compile, I'm going to have to compile them both. So when I do G++, I need to compile functions.cpp, my function implementations, and the unit test code all at once. I'm also going to change the name of the output executable to be lab7.exe. Oh, I don't have a catch. Why don't I have a catch? Let me get a catch real quick. My computer, even on my relatively decent laptop, still chews away at that catch file. Okay, so now if I run lab7.exe, it's going to run the unit tests, and I'm going to fail most, if not all of them. That's what I expected because all I did was stub out the functions. But it did compile and it did run. I'm just failing everything, but that's what I would expect to have happen. So now I'm going to start attacking these functions one at a time. We've already done read file. This one's fairly straightforward, but you're going to see it again. So what this function is going to do, it's going to open a file of a particular file name, load each line of that file into a vector, and then return the vector. So this will be, do we have the usings for this? We do. So stream input file, I will call it. So remember that when you construct input file with the file name, it attempts to open it all at once. So then you immediately make sure that it did get open. So if input file.is open, then it's okay to proceed. If the file doesn't open, by the way, then an empty result comes back, which is what you would want. Okay, so now we need a string to read each line of the file. So this just gives us a place to store each line as we read it from the file. And then we'll use a while loop while we are still getting lines from the input file and storing them into that string. So this get line will basically kind of return a false when there's no more lines to read. So it takes care of the problem of reading all the lines for me when I put it in a while loop. So while I'm still getting lines, so I'm getting a line from the input file and storing it into this string. What I'm going to do with that is push it back, push that line back onto my vector. So if you remember, the way you add so the name of my vector is result. Next line is a string, so result is a string vector, so I can push strings onto my string vector. So result's going to grow. Every time I read a line, it will grow by 1, and grow by 1, and grow by 1, and grow by 1. So there's that function, I think, implemented. So what I do is I immediately go back and recompile and see if I'm passing any tests now. So part of this is I want to make sure the code I wrote compiled, and the other part is I want to see if I'm now passing any tests. I have passed some tests. I'm going to run this with the -s, dash little s. Should show me, all right, so there I passed one. Here I'm passing some. I'm still failing a lot, but I am passing some now. And it's compiling. So one function at a time. All right, work my way down to uppering a string. So I will do it the way I do it, which is so I'm going to use the for each style of loop here. So input is a string. So if I for each loop a string, I get characters out. Some of you might remember that if I put an ampersand in here, I actually have a reference to the character, and now I can make changes to it. So I want to overwrite that character with the this is a standard library function to upper. It is not the same as my to upper, which takes string. This to upper takes a character. So I'm going to upper the character, and then I'm going to overwrite it. And since the character is a reference, I can overwrite it in place. So I'm going to save that, and I'm going to go back to my terminal and recompile. See if I'm passing any more tests. I think I was passing 7 before. I don't know where you would get that from, unless you change something. Did you change any of the files? No. So Sapphire, let me come back to that question. But first, so functions having the same name in C++, you can have functions with the same name in C++ as long as the arguments are different. So a function to upper that takes a string is legal to exist alongside a function called to upper that takes a character, because that's a different argument type. If you're getting a pragma once in main file, I don't know why that should happen unless you change something. So let's go through the files real quick. So functions.h has a pragma once at the top of it. Functions.cpp just has functions.h at the top of it. And then lab7.cpp just has this at the top. I feel like something must have changed if you're getting a warning. But if it's only a warning for now, just ignore it. Warnings you can ignore for now. Okay, compiled. I'm hoping to pass No, I'm still only passing 7, so that's not enough to pass more, but it did compile. Okay, so to lower, well, that's going to be easy. So I'm going to grab references to the characters in the input and overwrite them. And since it's a reference, overwriting C with the to lower of itself will work. And here's the same thing. So this function called to lower that takes a string is legal to exist alongside a function to lower that takes a character. C++ can tell them apart. Okay, if you didn't change anything, then for now just ignore the warning. It'll be okay. I'm pretty sure I'm not going to pass any additional tests after to lower, but I am going to go compile it real quick. And it's not real quick, but one function compile, one function compile. I'm going to go ahead and run the test, though, after I do each function, just to see if I happen to magically be passing something. Not yet. Oh, I see the problem. Okay, I am failing them because of bad code. So I'll show you over here. I'm seeing the tests on line 22 and 23. I expect to be passing those, and then I realize where my mistake is. So let's go fix that. So I need to fix to upper. So the first thing I need to do, in fact, the only thing I need to do in to upper, two things I need to do. This result here, I'm going to make result as a copy of the input. That's how you do that. Now result is a copy of the input. And then I will process the result in the loop instead of the input. So same change in to lower. So in to lower, I will make result as a copy of the input. And then I will process the result string in the loop, which should have me passing some tests now. Yeah, so now I'm passing 11, so that's good. All right, on we go. Returning account. Now I am, by the way, this to upper that I used with the character and this to lower that I use with the character, those are standard library functions. I just happen to remember those. We went over them on the Tuesday before, I think. Maybe even the Thursday before that, but I think the week before spring break we went over to lower and to upper. So digits, I'm going to use the same... and I'm going to use standard library functions that I happen to remember. So I'm going to process the input. I'm not taking a reference to the input because I don't need to change it. I just need to look at it to see what it is. And then I can use a standard library function called isDigit. So I get a character, and if it's a digit, then I increment my result. And then I'll go test that. All right, so I'm passing 2 more. I was passing 11, now I'm passing 13, so I'm pleased about that. I'll do punctuation now. Same idea. So I will use the for each style of processing the input. I'm not going to grab a reference because I don't need to alter the characters. I just need to read them to see which ones are punctuation. I'm again going to use the standard library function called isPunct. So if the character I get from the input is punctuation, then I will increment my result. All right, I'll build that and run the test again. So hopefully everyone notices I'm working on one function. I stubbed them all out so it would compile, at which point when I tested I failed everything. And then I just go and I hit one function at a time. I compile it and I test it. So now I'm passing 15, whereas before I was passing 13. Vowels. This one's a little bit trickier because you have to be clever about it. But I'll show you what I'm going to do, which is I'm going to set myself up a string that has all the vowels in it. Y, notice the comment says just A, E, I, O, and U. Hopefully you recognize that the reason why this string has big A, E, I, O, U and little A, E, I, O, U is so it will be case insensitive. So that's now what I'm going to do is I'm going to take the characters from the input and then I'm going to look to see if I can find them in my testing string called V. So take each character from the input. I don't need it by reference because I'm just looking at it. I'm not going to change it. Then I don't like this V. Let's call it something else. I'll call it all vowels. All right, so I have a character from the input. Now I'm going to grab in sequence each vowel that I'll call V from the all vowels string if the character and the vowel match, the character is a vowel. Does that make sense? So if the character from my input I can find by looking through the all vowels, well, that is a vowel. So I found another vowel. The other thing I can do here is make my program more efficient by breaking. This break breaks the nearest loop. So the nearest loop is this inner loop. So once I've found a vowel from all vowels that matches my character from the input, I can increment the result and then I don't need to look for any more vowels because I found it. At that point, when I break out of this inner loop, I'm returned to the outer loop and the next character is drawn from the input. That's how I would do this problem. And I'm going to compile and then rerun the test and see if I pass more than 15. All right, now I passed 17, so still going all right. All characters. Let me squish this up. So all characters just means the length of all the strings. So this is one of those where you sort of try to be clever to reuse other functions. So I have a different argument. So now I'm in the vector section. So I need to think, instead of collections of characters, I need to think collections of strings. So the loop now is to loop through, grab each string from the vector V. So this is the vector V up here. That's the incoming vector. So I will grab a string from the vector and I will simply grow my result by the size of that string. That's it. Because it just says count the characters. Well, that's the count of characters in a string is just the size of the string. So all characters of all strings in this vector should just be take the size of each string in the vector and accumulate plus equals a result. Go build and test. Normally, by the way, I'd go a little bit slower through this, but I'm trying to sort of cram 2 labs into one day. So that's why I'm going a little bit faster. Now I'm passing 18, so that's one more. All right, so when you get to this vector section, think, can another function sort of help me solve the problem? In the case of all characters, it was simply the size of the string that solved the problem. Now for all digits, I need to be more clever because there's no digit counting function in the standard string class. I'm still going to loop through, by the way, and grab strings out of my vector v and accumulate a total by doing something with the s. So what I need to know is how many digits are in s that I add to my growing total. And some of you already know this. I just wrote a function for that. I wrote a function called digits up here that, if given a string, returns a count of the digits in that string. So down here, right here, in all digits, if I pass my s to my own digits function, I get a count of the digits in that string, and then I just accumulate those onto my result. So this is an example of the concept of using your own function. Why not just use the function that already does that job and accumulate the results from a whole bunch of strings in a vector? So build and run again. So I'm passing 19, and I was passing, I think, 18 before. Yeah, so I'm passing one more. No doubt you can see where this next one's going to go. Punctuation. Happily, I have a punctuation function. So I wrote this lab to encourage you and to do this and to reward you for doing this, which is to reuse your own functions. And also so you can sort of see this for loop pattern repeating. Notice I'm not drawing the strings by reference because I don't need to change them. I just need to read them. So accumulate the result by using my own punctuation function on that string. So now I'm up to 20. I was at 19, so now I'm passing 20. You know where this one's going because it's the same thing. Don't need a reference to the string because I'm just going to read it, and then I will accumulate a result by using my vowels function on that string. So I get each string, count the vowels, and accumulate the result. And then by looping over the vector for all the strings, I get the total of all the vowels and all the strings in the vector, the collection. So now we're passing the whole test. All right, so let's see, it's 11:42. So I would like to, I'm just about out of tea and I need some water to keep my voice going. So I'm going to wait a minute or so and then I'm going to go, but anyway, I need about a 2-minute break. So I'm going to go get some water, come back in about 2 minutes and do lab 8. Does anyone have any questions for me though about lab 7 before I tuck that away and go on to lab 8? Now, I did go fast, but I will post the video, of course, at the end so you can go back through it. That's correct. Yeah, so Jackass are both Lab 7 and Lab 8 due by tomorrow. And yes, my goal is to use the weekend to get all the scores recorded. So if I can get it before I get up on Saturday morning to work, that's best for me. So yes, Lab 7 and 8. By tomorrow. Correct. I'll post the video, but not the source. Yes, Lab 7 and Lab 8 will both be due tomorrow. Now, once I come back from break, we're going to do the walkthrough on Lab 8, and then I'll post the video immediately after we shut down here. So you'll have the video immediately on YouTube. Okay, yeah, you can go back later and you can pause the video on all the spots. Yes, if you have errors and you just can't work it out, email me and I'll try to answer it. If you get a wall of errors, by the way, usually what works for me is, so if I get a tiny number of errors, I usually start at the top of the error list and work my way down. But if I get a wall of errors, I usually start at the bottom and work my way up. But yeah, you can. If you get a wall of errors and can't work it out, let me know. But the whole solution is here in this video, so hopefully that will also help. And it should be that you can pause the screen on the different segments. Okay, give me a moment. I'll go get a glass of water, and I'll be right back, and we'll do Lab 8. So if you need a break now, it'll take me about 2 minutes to do this. Okay, thanks for letting me get some water. Yeah, good point. Um, the Twitch automatically caches videos for, I don't know, like 30 or 60 days if you're not paying for their service like I don't. Um, and then I also post them up to YouTube just so they're there for longer as needed. All right, so let me do a quick changeover to the Lab 8 stuff. So my editor will be right back. So yeah, you have to have the wordless file because one of the tests loads it, and it also uses it for some of the other tests. I had that problem because I forgot to. In fact, I'm going to do that right now. Go get myself catch for my lab 8 because I don't think I had it in here. Okay, it is here now. Okay, so normally we won't go this fast. Normally I'll just spend 45 minutes to an hour. It just depends on questions. Going over concept on Tuesday and then slowly through lab on Thursday. Today I'm going a little bit fast because I'm trying to get these 2 labs so we can get back on track, having lost this Tuesday to the day that Butte College had us shut down. So normally it won't go this fast, but the videos will always be there for you to go back and review. And I'll make sure that the titles tell you what day it was, and usually I'll also add the subject matter we were covering. Okay, so now we're on Lab 8. And Lab 8 is a class to manage a collection. And the collection is a vector. So remember that I said is my setup. Usually when you create a class to manage a collection, that collection will have that collection will be a private member of the class, and then you'll have functions that perform the CRUD operations: create, read, update, and delete. So let's go look at the code here. So this lab has a test file, lab8.cpp. It has an implementation file, wordlist.cpp, and it has a header file, wordlist.h. So wordlist is a class, and it has a vector in its private. So it has a collection as a private data member. And the job of the wordlist class is to have functions that allow CRUD on this vector called words. So let's find the CRUD operations. Add word is the C, that's create, which is a way of adding data to the collection. This is part of the R, read. So in this case, reading the collection means just saying whether or not it contains a particular item. Get word count is also kind of a read operation because it's just giving you information about the collection. And to string is kind of a read operation as well because it's really just allowing you to print out information about the collection inside. So one thing you'll notice is there's no there's no update function here. There's no way to retrieve and update an element of the collection in place. So in this case, we don't actually have a full CRUD set of operations, just CRD. So remove word is a delete operation to remove one word. And then clear is a delete operation because it deletes all of the contents of the vector. So that's what this class is about. And I mean not CSCI 21, but the class word list. So I'll go about this the way I do everything else. I'll grab the functions from the .h file, copy them, and then I'm going to go open the .cpp file and paste them in. And I'm going to use the same approach that I did on Lab 7. I hope I read it. If I didn't turn on audio, I'm going to kick myself. Okay, I did. But someone probably would have said something in chat if I had messed that up, I hope. Okay, so I've copied all the functions into the .cpp file. Because these functions came from a class, they were all inside a class, they need the class : thing. So the first thing I'm going to do is word list : all of them, because they won't compile if I don't. You put the word list : on the function name. Be careful about that. So there they all are. I usually do that first because if I don't, I forget and then I get a compiler error and that's irritating. So this way of working just helps me not make that mistake. Now I'm going to stub. So I'm going to stub each function, which means I'm going to delete the semicolon from the function header, open a block. In the case of add word, it's a void function, so a stub can literally just be empty. So that's great. I don't have to do anything to make a stub there. So now I'll go to remove word. So this returns bool. So to stub this, I have to return something. So normally what I would do, this is just my own style, is I set up a variable of the type I want to return and give it some default value and then return it. So now this one's been stubbed. Remember what I mean by a stub is it doesn't actually work, but it will compile. Has word, I'll stub that, so delete the semicolon. Set up a variable that matches the return type with some reasonable default value, and then return that variable. And then in between, when I go back, I will do the work. This one returns an unsigned integer. And hopefully everyone gets the idea. The stubbing is here so I can more quickly get to running the compiler on it. And then I can work on one function at a time. Once I get them all compiling with stubs, then I can start to flesh out the individuals one at a time. Clear returns void, so stubbing that just means putting an empty block in there. Word list down here. Returns a string, so I'll just do that. So now I got stubs. And then I'm going to go try to compile it and test it and see what happens. So in Lab 8, I have 2 CPP files, so I need to make sure that they're both getting compiled for the final product, and then I'm going to change the output file to be lab8.exe. I got a name mismatch. So the file wordlist.h has little w and little l, and somewhere, here it is. So notice here in lab8.cpp, I have it typed in with a big W and a big L, so I'm just going to change that so it compiles. I don't know when I did that, but at some point I changed that. So I need to make sure that wordlist.h matches case sensitive everywhere. And I was getting an error from lab8.cpp line 7, and then I noticed, oh, I spelled it differently there. So hopefully that's fixed. I should fail a bunch. Somehow I magically pass some, but I do fail a bunch. All right, so compiling, failing a bunch of tests, but compiling, and once I get it compiling with stubs, now I can just focus on one function at a time. Yeah, let's just go, well, we'll start at the top, and then when we get to the harder functions, we'll skip them and come back to them. Adding word is easy. If I remember from wordlist.h, every word list has a words vector in it. No. So the word list from Lab 7 was a text file with literally words in it. The word list here is a class with two source files, wordlist.h and wordlist.cpp. They're different. There's no text file in this lab. It's just code. All right, so every word list has a words vector in it. So to add a word, I go to this word list words, and I push back. So I have a word coming in. I push it back onto the words vector of this word list. Save that, and then I'm going to go build and run it. Make sure it compiles first, and then see if I get lucky and pass anything else. I don't expect to, but maybe I'll get lucky. I didn't. I'm still failing the same number or passing the same number, but that's okay. It compiles. Okay, remove word. That's a hard one. I know that. So I'm going to come back to that in a second. Has word's not too bad. So let's do that. So to know if my word list has a word, I have to look through the word list's words. So I'm going to use something that I used in Lab 7, which is I'm going to go grab strings from a vector. Now in this case, the strings are from this word list's words vector. I'll just grab them and call them S. I'm not going to do that by reference because I don't need to change them. I just need to look at them. And then if that S that I got is the same as the word that I'm looking for, so I'm looking for this word, if the S that I get from my vector, well, that means I have it. So I actually have it. It's true. And once I've found a match, I don't need to look anymore. I can break out. So that'll break and immediately get the result back. If I never find a match, it will never become true and it will never break. It'll just have to process the entire vector until it's finished. Let's see if I pass any new ones now. I passed one more, which is better than 0 more. So that's a start. Notice, by the way, I've left remove word behind for now. That's a harder one. I'm going to come back to it. So has word, it compiled, and I passed another test, so I'm feeling good about that. Return the number of words, i.e. the size of the vector. So all it really wants the result to be is the size of this words list words vector. And if you know how to optimize this, you can go ahead and do that. But I'm just sort of using a reusable model here. Variable, work, return. So my result in this case is simply how many words do I got in this word list's vector. Compile that. We don't have too much longer to go, so thanks for bearing it out. We won't go this long normally. That's just catching up from missing Tuesday, remember. I'm passing less. I'm bummed. Probably it's because remove doesn't work, but that's okay. It compiled, so I'm going to keep going. I passed less, which is kind of funny. My guess it has something to do with not having done remove. That's okay. We'll keep going. I feel confident that this is correct. All right, we did get word count, which is the size of the vector, so that's all that was. Clear, that one's easy because I can grab the words vector and it has its own function to do that, so I'll just do that. And then I'll recompile. Make sure that I'm at least compiling, and I would be happier if I'm passing tests in the meantime. I passed 21 again, so at least that's progress of some sort. All right, let's go back to string is probably slightly easier, but let's deal with the remove word now. Okay, this one's tricky. The function to do this is called erase. So if you look up standard vector, we're going to use erase. All right, so here's the trick about this one. It's possible that a word is in the vector more than once. And I'm pretty sure from looking at the test, yeah, so if you look at the stress test section of the unit test, it adds 100 hellos and then does a remove on it and expects for it to have removed everything. So what that tells me is that my remove needs to remove all of them. So we have to keep that in mind. So here's how, it may take me a couple of steps, but let's set up for this. I happen to know from experience, size t is an unsigned integer. And then I want you to notice that I'm leaving this last section blank. And I'll explain why here in a second. But I'm not actually advancing I in the for loop. But I'll explain that to you as part of the algorithm here. So I'm not using a for each style of loop this time. I'm using an I equals 0, kind of like an array type of loop. Okay, so what I'm looking for is everything that matches a given word. I want it out of there. So this time I'm going to say if the words vector at a position, so that's more like the array access style. So I'll use the I to access the vector at a given index, starting at 0. If that thing matches the word I'm looking for, then I'm going to use the erase function to get rid of it. So has an erase function. This part's going to look a little bit nasty. This is an iterator. We've spoken about iterators before. This is a marker at the beginning of the words vector. And then I'm going to say from that marker how far over to the spot I want to delete something or erase something. And that I will give me that. So the I says how much over from the beginning. So for example, if the first word in the vector, the 0 word in the vector, is one I should delete, then this will be from the beginning over 0, which means from the beginning. Now notice that, and I may have to try to draw a picture for you of this for you to get it, which I'll try to do. That's a hard one to draw. I'll try to figure out how to. Yeah, let's go to Ziteboard and try to do that. Oh, you can't see that. You cannot see Ziteboard. Hold on, I'm getting Ziteboard where you can see it. Okay, so I'm going to try to draw you a picture of what's happening here. So what I'm trying to explain to you, for you, is why I'm not moving the eye. So why am I not moving the eye? So that's what I'm trying to explain here. Let's see, how do you... I want to get rid of all this crud, so how do I just clear it out? No. No. Is that really how this is going to work? It's close. I'll get there. Put some stupid dots. Ugh, what is all this mess? Alright, anyway, I'm just going to try to draw it. So, I'm just going to use letters here. So if you have a vector with A, B, C, D in it, and you erase A, this is position 0, position 1, position 2, position 3. I have a mouse and I'm not using it because I'm stupid. If you erase at position 0, what you end up with is this. So notice how the B kind of pulls back and now becomes the new 0. So the point of not moving the I when I erase something is because I know everything just stepped forward one. And if I were to move the I, so if you think about it, if I remove, pardon me, if I remove the 0th element, when I is 0, and these all slide forward one, and then I move I, now I is 1, and I can't erase B. So if I had a list that looked like this as an example, where I'm trying to erase A, three, and I erase 1, those are bad drawings. So in this second example, if I erase the first A when I is 0, and then I move I over, I++, I accidentally skip over the A that is now the 0th element. So that's why I'm not moving the I. Hopefully that makes sense. Yeah, I even have a mouse and I didn't connect it. Now I don't feel like getting up to get it. So it's not a pretty drawing, but it'll do. If I can now. Hide that. Okay. So that's why I'm not moving the I. But, the other thing is, if I erase something, then happily I have succeeded in erasing something. So I can set the result true. But because that word may be in there more times, I'm not breaking. I need to keep going because I need to find all of them and erase them. On the other hand, if the position I'm looking at is not the word I want, then I am going to move the I. Because I need to go to the next one over. Now this will still catch, so it'll still, once it gets to the end, it should still stop. But that's the idea. This may not be bulletproof, but let's give it a shot. Yeah, the drawing. So ideally I'd have like a Wacom tablet or something, but since everybody in the world is online, like all that stuff is bought. I'm passing 38 now, which is great, and I'm noticing all of my fails are the toString function. So that's exactly where I want it to be. So anyway, that's a tricky one. You might have to take some time to study over that algorithm to kind of get a sense of what I was trying to draw a picture of and how this works. One thing I've done for myself is I've made sort of my little vector with the index cards and drawn words on them and try to repeat some words and then apply my algorithm, tracking where my I is and see if it still works, is what I've done. Okay, so the last one is toString. Let me push it up. Which is supposed to do this. So numbers and names. Numbers and squares. And it's supposed to return a string, which means, if you remember, the easiest way, in my opinion, to do this is to create a string stream. And then populate the string stream with data. So when you're working with a vector, you have two choices. You could use this kind of string, or this kind of for loop. And then what you're wanting to do is populate as a space behind it, followed by the S, followed by an n-line marker. So this is the basic algorithm. Problem is, I don't have the numbers to put in here. So if you use a for each loop in C++, you don't get the index values, and sometimes those can be useful. They're totally necessary. For example, I need the I to remove words with that erase algorithm. So I used this kind of loop. But it turns out that for making a numbered list, this for each loop isn't the greatest because I would like to have the I to print. I want to do this. And because I want to do that, I'm going to use the other kind of loop. This time I'm not doing any weird algorithm, so I can just I++ it. And then I don't have an S anymore, but I do have a this words at I. Now, if you know I'm about to fail the test, then you know what I missed. And you can say in chat if you want to. I'm failing on string stream. Let me go back to wordlist.h and see what it wanted me to use. An O string stream. That's for outputs, which is what I'm doing. So I can take the O off, which is what I'm going to do. Sure. But I could have, in fact, I changed my mind. I could have here used an outputting string stream in my function. That's what I decided to do. End line is not declared. Notice I'm getting an error about end line. So it must not be in the using, and I'm just going to get around that by putting an actual new line character. Because I don't feel like going back and putting a using directive for it. All right, still failing them. Oh, because I'm returning empty strings everywhere. So I've got to fix that first. The result equals the stringified version of the stream. Forgot that line of code. I got to take that string stream and convert it back into a regular string. And then recompile and retest. All right, I'm still failing, but these fails are pretty easy to pick off what I've got wrong. So this last one, I'm printing a 0 where it expected a 1, and here a 0, 1 instead of a 1, 2, a 0, 1, 2 instead of a 1, 2, 3. So if I look up here if I go back to the code and look at the example, it doesn't want me 0 numbering, it wants me 1 numbering. So down here in the for loop, if I change this I to be a 1, I'm accidentally passing over the first item of the vector. So we just used the little trick. So where I print out this I, just make it 1 more. Doesn't change anything, it just makes it look like 1 more, and that'll satisfy the test. Human numbering, if you will, right? Not computer science numbering. All right, so now we're passing all the tests. That O-string stream thing, I'll just go. So there is a generic string stream that you can use for this, which I would have to change that in wordlist.cpp and at the top of wordlist.h. Or you can use the output string stream, which is specifically for doing outputs like we're doing on. You can use either is fine. I know that when I wrote it, I decided to use the output string stream. But I could have used the all-purpose string stream had I wanted to. Okay, so apologies again that the labs are going to be kind of spoily like this. But I want you to have all this material sort of repeatable since it's harder for you to interact with me and it's harder for me to look at your code. But you still have the projects, remember, and those you still have plenty of challenge in those for yourself. But you can also work the labs ahead if you want to and then sort of compare your efforts with mine on the day of the broadcast on Thursdays. Or you can not attend the broadcast and watch the video later. Let's see. So my last thing is just in chat. Is anyone interested in me setting up a Discord? Okay, so Davis, I'll answer that. Let me answer Davis's and then I'll re-ask my question. So yeah, for you only need to send me the files that you touch. So for Lab 8, it would be wordlist.cpp. And for Lab 7, it would be functions.cpp. So those are all you need to send me. Okay, so thank you on chat. I see some people at least would consider Discord, so I will set up a Discord and get you all invited, and we'll get going from there. I may not get to that because I have another class to do this afternoon, so I may not get to that till tomorrow morning, but I'll let you all know. Please watch your Butte College emails. Probably you already are, but that's the by far the easiest way for me to get word out to all of you about something is in the Butte College email. You don't have to email me with your materials with your Butte College email. Just please watch that for communications. All right, so I'll set up a Discord. You only need to send me the files that you wrote code into and nothing else. And now I'll sit here for a few minutes and see if there's any questions I can answer. And otherwise, I will shut up for a second. Thank you all for being here. We won't go this long normally, but I wanted to catch us up from Tuesday. And hopefully we'll figure out a way to make it work for all of you. And brace yourselves for the crappy drawings because I'm going to use that Sightboard. I'll try a mouse, but I don't have a Wacom tablet to make that less painful. Thank you. Appreciate it. Sorry to you assembly guys. You had a long day with me. We'll try to keep the broadcast not going so long all the time. Thank you. You too. Okay, last call for questions. No, you can do the labs however you want. As long as they pass the test, you can solve them however you'd like to solve them. So that's all good. Okay. Do I have the? Okay. Yeah, I'll leave the string function sitting there. Yeah, so the TAs are still out there and available. I'll probably hook them up in Discord and then let everyone figure out how they want to communicate together. But yeah, Andrew and Dylan are still out there, ready to work. So the good thing for them, if you take advantage of their services, is that they still get to make a little bit of money while we're in this weird situation. So yes, and I'll add them to the Discord, and then people can kind of arrange to communicate with them however they would like to do so. Oh, hey, Dylan's here. So Dylan, I'll add you to the Discord for these classes if that's all right with you. I haven't asked the PNA one group yet. It gets better all the time, Discord. I've had occasionally, like there were times in its lifetime when it wasn't the best, but it seems pretty good now. All right, everybody. I will see you on Tuesday at 11. Feel free to email if you have questions, and I'll do my best to answer them. And um, we'll just proceed. I think after today we're caught up, so we should be all good to go. So I'll see you on Tuesday.
Everybody to the Wild Wild West, a state that's untouchable like Elliot Ness. The track hits your eardrum like a slug to your chest. Like a vest for your Jimmy in the city of sex. We in that sunshine state where the bomb ass him be. The state where you never find a dance floor empty and pimps be. On a mission for them greens, lean, mean, money making machines, serving fiends. I've been in the game for 10 years making rap tunes. Ever since Honeys was wearing Sassoon, now it's 95 and they clock me and watch me diamond shining, looking like a Rob Liberace. It's all good, from Diego to the Bay. Your city is the bomb if your city making pain. Throw up a finger if you feel the same way. Straight putting it down for California, yeah.